All right, we're going to look a little bit more at simplifying radicals to the nth root. So we talked about yesterday about how that sometimes yesterday we saw, or in the last lesson, we saw that all of our simplifying was a whole number or worked out evenly. Now we're going to look at like what happens if I have some things left over. So again, we are going to simplify these powers, and we are going to pass that through. So when I'm looking at this, I want to factor this 144. So I'm looking for groups of 2 because my index is 2. So I'm going to take 144 and I'm going to factor it. And if I can find the square root of it and know the square root of it, then that's fine too. So you might know that the square root of 144 is 12. But if you didn't, you could again simplify this out. So 72, divide by 2 till I can't anymore. Looking for groups of 2. Divide that by 2, I get 18, 2, 9, 3, because I can't divide 9 by 2, and I get 3. So I'm looking for pairs. There's a pair of 2s, so they go out. Here's a pair of 2s, so it goes out. And here's a pair of 3s, so they go out. Right? And then I'm going to take my powers and I'm going to divide by 2. So this would be x to the 4th, because 8 divided by 2 is 4. Now when I take y divided by 2, I wouldn't want to do y to the 2.5, but 2 will go in there twice. So that's how many pairs I have, but 1 y is left over, because if I take 5, divide it by 2, I get 4, and a remainder of 1. So here's the power of what's outside, because that's how many total pairs I have, and this is the power of what's inside. Notice this power here is not greater than the index of 2. And then I would want to go ahead and multiply that, so I would get 12 x to the 4th y squared square root of y, and your index or your radical should look the same as the original radical if there's anything left over. So these all went out as pairs, this was left over, so that's why it's underneath the radical. So let's look at another one here. First we're going to multiply these. So since these are like, we can multiply the outside, so 7 times 4 is 28. And then I have the cubed root of 64 times 8, which is 512. And then n squared times n is n cubed. So I am looking for groups of 3 because my index is 3. So I could check to see if this is a perfect root of cubed root, but if I'm not sure, I again could go 512, 512, divide by 2 till I can't anymore, 256, 2, again, because I can divide that by 2, 128, 2, 64, 2, 32, we get a lot of 2's here, 16, 2, 8, 2, 4, 2, 2. So here's a pair of 2's, goes out with the 28, that's already out there. Here's another pair of 2's, so they're going out as pairs. Here's another pair of 2, so it goes out. And, goodness. I'm looking for groups of 3 because my thing is 3. So here's a group of 3 2's. So it goes out. Here's a group of 3 2's. So they go out. And here's a group of 3 2's. So that goes out. So no numbers left over, so I don't need anything underneath the radicand. And then 3 divided by 3 is 1. So n to the 1, and there's no remaining n's. So nothing's left over, so there's not a radical left over at all. And then I would do 28 times 2 times 2 times 2, 224. And again, nothing left over in the radical because everything divided evenly or factored evenly. All right, let's look at a couple more here. So square root means I'm looking for groups of 2. So I take my 40, divide it by 2 till I can't. 20, 2 is 10, 2 is 5. Here's a pair of 2's, so it goes out. The 2 and the 5 have to stay back because they don't have pairs with them, so that's 10. And then 3 divided by 2, 2 will go into 3 once, and I will have a remainder of 1. So then that would be my answer. 56, factor that out. So can use prime numbers here that I'm dividing by. Smallest prime is 2, and then keep going. So I have a pair of 2's, looking for a pair of 2's because my index is 2, so that goes out, this pair of 2's, and the 2 and the 7 have to stay home. I'm going to write it a little bit over to the side. And again, notice my radical looks just like this radical. And the 2 and the 7, so that's 14, has to stay home. 6 divided by 2 is 3. There's no a's left over. 9 divided by 2 is 4, with 1 b left over. 11 divided by 2 is 5, with 1 c. Notice these powers of the b and c should not be more than 2 since my rad index is 2. So we'd go 54, break it down. Can't divide that by 2, so I go to the next one, 3, 3, and 3, looking for groups of 3 because my index is 3, so there's a group of 3, so that goes out. And this 2 stays home. This is a cubed root home, so it needs to stay a cubed root home. Then 3 divided by 3 is 1, so x to the 1 with no remainder. 5 divided by 3 is 1 with a remainder of 2. Power is 2, but my index is 3, which is greater than 2. So just kind of that same process through all of those. Try these last two. Multiply first, so you'd have 48 square root of x cubed y to the 4th, and then simplify that. That 48's underneath. 48 x cubed y to the 4th, and then the square root, and then you would simplify that down. Same thing here, multiply your 9 and your 27, your x's and your y's, and then simplify. So these are the answers, so check that, see if you get those correct answers. If not, try to figure out what you did wrong. If you have any questions, let me know.